Where does the area of a kite come from? You find the area of a kite by taking the two diagonals, multiplying them together, and finding either a half or dividing by 2. But why does this work? Again, it has its roots in either using the areas of triangles or using the areas of parallelograms. Let's first look at the triangle. Now, the one thing that the diagonals of a kite do is the yellow, diagonal 2, bisects diagonal 1. So it cuts it in half. So let's look at this from a triangle standpoint. Okay, in this kite I have two congruent triangles. I have the pink one and the green one. How do I know they're congruent? Well, my background knowledge in transformations lets me know that a kite has one line of symmetry. It's down the middle. Okay, therefore that's also it has reflectional symmetry, and that line of reflection makes this diagonal the same as that, this side length the same as that, and these two side lengths the same. So I know that if I find the area for one of these, all I need to do is double it, and it will give me the area for both. So let's try that. So now this might get a little confusing, but the height of each of my triangles, the pink and the green, is actually equal to 1/2 of the of diagonal 1. Okay, so the area for the first triangle is 1/2 times 1/2 d1, which is height, times d2. I want to add to that the area of the other triangle, which will also be 1/2 times, times half the first diagonal times the second. Okay, again, we're going to do this. This is not going to be a point at which I necessarily can factor, because I have the same thing in both pieces of my expression here. But what I can do is I can multiply these fractions, which is going to give me 1/4 d1 d2 plus 1/4 d1 d2. And what's 1/4 plus 1/4? It is 1/2 d1 d2, or diagonal 1 times diagonal 2. Okay, so this is where one way in which the area of a kite can be derived is taking half the area, or finding the area of the two triangles that make up the half and adding them together. Now let's look at the rectangle, or parallelogram I should say. So let's say I take the green triangle apart and I flip this piece over here and I rotate that piece over there. Okay, now we simply just have a rectangle with a height of half the blue, so half diagonal 1, and still a length of diagonal 2. So again, here's our area formula for a kite. Okay, so our area formula comes from either two triangles created by reflection or one big rectangle created by rotation.